think we're going to begin with the talk. So yeah, I've been here before while I was in the presentation for when Rob Conrad was here, and well, for me it's really a pleasure to talk about HaxeFlixel. Well, one of the reasons I'm a Haxe user is because I come from the Flash programming world. That's how I got to start. And when I found out that Flash was going away, well, I had to find a way of how to preserve the things I did, and I could in part thanks to OpenFL. And HaxeFlixel, in some way, keeps that as well. There used to be a library made by Adam Atomic, like the guy that made Cannibal, and he named it Flixel. And the library was good enough for prototyping and doing stuff. And when OpenFL became popular, like people decided, okay, we can also port Flixel to OpenFL, and that's how HaxeFlixel was born. So yeah, the talk today is about the library, a framework to make video games. HaxeFlixel works with OpenFL underneath, so that means that it can compile to Windows, to mobile, and to HTML5. I decided to focus in HTML5 only, just not to talk about the details of other platforms. Like if you want to use Windows, and that means that you need Visual Studio running around, and that's an extra step that I don't want to get into, but it's not too hard. So if the ones that are looking this through streaming, please know that you can find the slides at the address that you find in the slide, so that way you can also step through the slides with me. So yeah, I come here as an amateur, game designer. Amateur is usually associated as a beginner, but it's much more interesting word. It means the Merriam-Webster defines it as someone who does things out of love and not because it's done professionally. And I work in the video games industry, but I still make games that are related to my life. I used to live in Venezuela, and I'm living here for about 4 years, but I still do things that are related to that. And the games I do are usually not commercial, but are more related to things I've lived. And I find that games that are done like that are very interesting and are very inspirational. And it is with that spirit that I want to give this talk. So, okay. So today's agenda is quite packed. Hopefully I can do this talk in an hour. But we're going to install HaxeFlixel. We're going to create a HaxeFlixel project, see how the structure is. We're going to see what is it about the states, sprites, and groups, which are very basic elements of HaxeFlixel. We're going to use the FlxG frontends. FlxG is the static object that you're able to query for the game state. We're going to look at how Flixel handles collisions, about timers and tweens, a primer about tilemaps, how to do input with HaxeFlixel, and we're going to see a little bit about add-ons. So hopefully we're going to be able to cover that in an hour. So first of all, I don't know how many of you have done games, your own game industry, or you might be an application programmer. So the domain might be a little bit hard to understand first. If you're an application programmer, you usually work with specific events. So the player, in this case the user, clicks something, the user presses a key, and the application answers, gives you an answer. And in the case of video games, programming is a little different, because the game is always running, and not doing something is also part of the input. The game is always running, and so the state is always changing. So I think that's one of the main differences between applications programming and video games programming. You always live within that update tick. It's always running. So first of all, I think you're all Haxe users. Is there anyone that has no idea about? If you all have idea of how Haxe works, then that's fine. I don't know through the streamers, but I'm going to pass this a little bit quicker than I thought. So, well, as I told you, I come from Flash programming. OpenFL was the gateway drug for Haxe, so let's call it that way. Because, well, OpenFL is, I think, is one of the examples of how porting an API is really useful when you want to pass through platforms, and that was my case, because I was having this amount of games that were done in Flash, but as time passes, I see the window that says Chrome. Now Chrome says, well, you need to click to start, or we don't even support MPA API, so Flash is definitely going out real soon. But yeah, I mean, I make 2D games. I make games with sprites, and for my case, I find that Unity, things like Unity, I'm going to mention Unity because it's one of the most popular. It's way overkill for me. So I find that this environment for programming is very convenient. And at the same time, one thing I've always wanted to do is I want to make a game that where I use the same language for the client as well as for the server. So Haxe is able to compile to PHP or is able to compile to C++. So if I want to make a game, I haven't done it, but I would like to, a game that has a web interface, then I can make the game in such a way that it compiles to PHP, or if I want to make a game that works in real time, then I can use library that allows me to do that kind of stuff. And for example, I was researching and I find that there is HaxeWS, which allows you to have WebSockets if you want to have real-time games for HTML5. Or there was another platform, there was another library that allows you to do real-time games, but I forgot the name. But yeah, the possibility is there. I'm probably getting ahead of myself. So, well, Haxe is the language and also the compiler. It's a language that is transpiled to other languages. So that means that the Haxe language is compiled to another language, and then a compiler for that native platform is what finishes the job. And also it has the Haxe toolkit also has the HaxeLib, which is the command line package manager. So here are some of the constructs for useful constructs for Haxe. You have type deduction, which is really nice. You don't need to declare your types, but also it's strongly typed, so it won't allow you to do things like summing a string and an integer, with JavaScript can. Iterations are done. It's not done as in the way of C++ or C. You have to use lists. You don't need to cast into when reading an array. That means that you have generics. And also you have macros. For example, I found out that this little library called ROPS I18N, which allows you to do localization. And it's very useful because you use this macro and then you, for this, say that you have a string like this one. Oh, let me check if I have. You have a string like this one, and then you can add the macro, and then you can call a new function for that string, and then the macro code reads that line and then outputs an XML file, which I can use for translating. So that's very cool. There are other Haxe constructs. This one I think is fundamental, in which expressions can be, if constructs can be used in expressions, so that's very useful for initializing stuff. Some people say argue that you could have a lambda function in another language where you insert this if and then you execute the function and then you get the result. But this is much more compact. But you have the enums, which are are much more powerful than I really thought. You have pattern matching in this case, in which you build this enum and then you can pattern match it here in a switch, and then you can use it as you like. You can even have enums inside enums, and it's really crazy stuff. And then well, the type def, which is used quite often in HaxeFlixel. So how do you develop for Haxe? You use Haxe Develop if you have Windows, which allows you to install Haxe and all the toolkit. If you have Mac, you can use Haxe Develop with Wine, or you can use Atom. If you have Linux, you can use apt-get, or well, if you use Debian, for example. And well, once you install it, you can call HaxeFlixel. HaxeLib to install FlxG. So in order to install it, you have to install several packages. The first one of them is FlxG itself, which is the core framework. FlxTools, which allows you to create skeleton projects. The templates, which allow you to, they're the skeletons themselves. The add-ons, which are very useful stuff, but it's not precisely core. And then you also have the demos, which are very useful to learn how to use the API. And you also have a UI library, which I haven't used, but apparently is very useful. Then you have to run Lime setup, and then you finally run the setup with FlxTools. That's what you have to do for HTML5. You also have to run setup for Windows if you want to use it. One of the problems I found out with HaxeLib, now that you've used Haxe before, is that and one little criticism about HaxeLib is that the problem of the global state, in the sense that it is the library versions that you have selected are selected for all the projects that you have installed in your machine. I don't know if you have had that problem, but since HaxeFlixel is in constant development, I found out that I do a game at a certain point, and a year after, HaxeFlixel has evolved a lot, and then they make breaking changes, and then I need either to port my games to the latest version, or have to do some sort of juggling with versions in order to make it run. And that's something that happened in the past Haxe meetup with Rob and Ka. He tried to solve it by trying to version control all the libraries within his project. And it's a clever way of solving it, but it only solves it for him. And I know that there are other package managers that allow you to specify the version that you need for your library. And it allows you to set it per project. So that's very helpful because you want your project to respect the library versions that you use. Well, at least Composer does it, and Cabal from Haskell does it as well. So I think that's, if you know a solution for that, then you might revolutionize Haxe community. So once you've installed this all, you can create a project by calling FlxL tpl-n myawesome project, or if you don't have flxl.bat installed in your path, then you have to run it through HaxeLib. So if you can do this right now, I'll run this right now. So if you do HaxeFlixel run FlxLtools tpl-n myawesome project, then it will create a template. Since I've got FlxL already configured to use HaxeDevelop, it will open HaxeDevelop at once, and it will show me the skeleton. So we can see here that there's an assets directory. It's got here a structure that is suggested, but it's not, you don't have to necessarily follow it, where you have the data, you have your images, music, the sounds, and finally the source. So in Haxe projects, you have the main object, which is the one that's getting compiled, and your entry point, and then you have states. So we'll get that into a minute. Oh. So yeah. So here's the project structure, as you just saw it on in HaxeDevelop. So the thing. Let's get into the, so first we have the project.xml. That's a very, I think it's an OpenFL file, which allows you to add the libraries that you need to your project. So if we see it from here, we can check that, well, it's an XML that allows you to set a lot of parameters that you don't need to focus on them at first. But it allows you to set the height, the width and height of your window, which is one thing that you might want to set at first. So if we see the main file, we'll find that it's quite simple. So this is the interface between OpenFL and FlxL. So we can see that this is a sprite, so this is an OpenFL sprite, and this is the last thing we will see about OpenFL. HaxeFlixel in that sense is very independent from OpenFL, even if the whole thing runs underneath. So the first thing we have to do is add a child that's FLX game, and then we set the width and the height of the game here. The thing with Flixel is that it allows you to set the zoom of the game directly. It's a library that is focused on games that are oriented towards pixel art. So you are able to make your game, say, in a very small resolution, 320 by 240, but you can set the game you can set the window 3 times that, and Flixel will handle the zoom automatically, and it will handle the zoom in such a way that it looks pixelated. It won't look like you scaled it in Photoshop with gradients, you know. Yeah, it will look okay. So there are several things, several parameters in here, like width and height. If you set them to 0, then it will set the zoom the same way as you set in your project.xml. Then you set the initial state where you want to start your game, the zoom, the update frame rate, the draw frame rate, then whether you want to skip the splash. You usually want to, because the splash of Flixel is a bit annoying. And then whether you want to start full screen. So this is the last time we'll see FLX game in here. What you usually write is states. So a state in Flixel is where the action of the game happens. So you have a function that's called create, where you create your stuff. It's not created when you create the state, it's created afterwards. It's for creation. And then you have an update function, which is the one that updates the game each tick. So this is the blank one. This is the one from the skeleton. But you start filling it with stuff. In this case, I've added here a text. I've added here a sprite. And the cool thing is that if you change the states, you can have several states which handle several things. Like you have a state for the menu, you have a state for playing, and if you switch states, Haxe will handle the destruction of the objects. So that way you can, it's very easy to reason about this code. So yeah, one thing that we noticed from here is the FlxG object, which is it's a class that holds a lot of static properties and functions, and it's what you usually use for querying the state of the game and to call certain functions. You mostly do it all through FlxG. We'll talk about it in a few minutes. But let's talk first about the sprites, groups, and the assets. So the sprite is usually what you load as an image, but you could also load an animation, or you could also create your own sprite. So this is first case. So we create first a sprite, and then we create a graphic. So in this case, when I call make graphic, I say I want to have a sprite that has this width and this height and has this color. So that's very useful for prototyping at first. If I want to have just squares, it's very easy. Just create them programmatically, and then you add them to the state. You can also load sprites from an image. In this case, you call the root of the root of the project is the root of your files. So you call assets my sprite. Also, the skeleton has an object that's called asset paths, which is a macro that scans your assets directory and then puts them in this way. So the autocomplete helps you to find those files very easy. The only quirk about asset paths is that it scans your files but ignores the directory. So if you have files that are named the same, even if they're in different directories, then it will complain the macro. That's something that happens with asset paths. And you can also generate the sprite in such a way that you can load the graphic and generate the rotations. So it doesn't generate the rotations in the middle of the game. It just reloads them, and then it becomes very fast. So in this case, you pass the name, the file name. You pass how many rotations you want to generate. If it's a sprite script, then you select the number of the frame that you want, and well, whether you want some anti-aliasing for it. And out-of-buffer means that it will grow up the sprite a little bit so it can hold the rotations inside. Otherwise, it will cut them of the rotation. So yeah, that's pretty much what you can do with sprites. This is a sprite strip. This is something I took out from Kenny.nl. He has a lot of assets you can use for prototyping your games. In this case, it's a character. It's being posed already. The original assets includes like different parts of the body because it's supposed to be become a part of a skeleton. So it could have more detailed movement. But in this case, this is more than enough for our purposes. So it has a lot of positions there, but you have to note which. So it's starting from 0. You have to notice which frames are there. So this is a strip of images that have the same dimensions, width and height. And when you want to create animation, you create the sprite, and then you load the graphic by telling I want to load this file. It is animated, so this is true, and then you set the frame size, and it loads automatically all the frames for you. And then you call this front end, that's the name of it, where you add the animations. You put them a name as a string, and then you add and you specify as an array which frames is that animation composed of. And afterwards, well, you have a speed of the animation in frames, and you also set whether you want to flip the frame in the case that you want to. If you have a walking cycle that can be flipped perfectly, then you can flip it, and you do it through this interface. And then you call sprite.animation.play and the name of the animation that is what is going to play. But by the way, I'm creating the object, and then I'm calling the object parts directly through this. But you might put this as part of the class constructor in order to have a better separation of responsibilities. So you'd have something like this. So this is code that is a bit more cleaner. So you only have to create the character, and then the constructor takes care of loading the animations. And you can generate this. You don't have to copy and paste the animation everywhere. You just do it as part of an object that extends the sprite object. So groups are, we just saw sprites. We can add sprites to groups. In fact, the state is also a group. And the groups, you can use the groups to group sprites. So that way you can have layers of sprites. So you can have a layer for the background where you add the background sprites in there, and then you add the group, and then in another group you add your foreground characters, and then you add them to the state. So you'd have them quite separated, separated very elegantly. They're also useful for collisions. We'll see that in a bit later. And you can, because the groups use generics, you can have groups of tilemaps, or you can have groups of sprites, and you can also, there's an FLX sprite group that allows you to set directly hierarchy of sprites. So you could have a sprite composed of several sprites, and then you can position them as you like. In order to create it, you just create a group, and then you add the sprites as you see fit, and in the order you want, and then you add them to the group. So other thing that you have are texts. So in the texts you have, the texts are sprites as well. In this case you have the position, in X and Y. You have the width of the text, and then you have the text itself and the font size. This usually uses a font that looks like a Nokia cell phone. That's the default phone, and I haven't used another font because I've been a bit lazy, but it's good for my purposes. It works if you use another font. And then you set things like the alignment. You can also set whether you want to wrap the words, and then a color for it. Here's another thing with HaxeFlixel about the design. So thing with things like FLX text, I'm going to talk about it, is that you get a lot of, you have a lot of parameters. I had a bit of a hard time trying to show you the parameters in here, and when you're writing code, you usually have to refer to the either to the autocomplete or to the documentation to see, okay, what's the order of the parameters, x, y, width, text. It's a bit annoying because I prefer to have that rather self-documenting. And the problem is that if you have many parameters, then you have to add them all, and then that you can make some breaking changes if you want. And this is not very, and then I have to set the alignment somewhere else. It's not very elegant. And there are other libraries that have handled this very well. There's a library called Lux, well, it's part of Snow, which prefers to build objects beginning with type defs. So the type defs allow you to specify a struct, and that way you build a struct by specifying the name, and then you specify the object. So when you create the object, you see the name of the parameter that you're creating and the value of that parameter, and that's very helpful for yes, it's very helpful for figuring out at that piece of code what am I doing. So yeah, that's some small criticism for Flixel. Flixel also has to carry over with its own baggage of, okay, I have all this code that depends on this. If I do this change, then I'm going to break a lot of hearts, and yeah. So FlxG is is the most commonly used object within Flixel. It allows you to query things like the height of the screen, the width of the screen, allows you to make collisions. It has those functionalities broken in what it calls front ends, because it used to be like a huge object where you had to hold you had all these functions, and it's a bit difficult to hold them all in your head. So that's the way that style of programming might be, I don't know if it's called controversial, because well, lots of people might not agree with, okay, I have all these static functions everywhere and I have to call them at this point. I'd rather to have another kind of design, but well, this is what Flixel gives you. So I'm going to talk about just a few selected front ends which are very useful. In this case, you have log. So log allows you to log the object into the output a line in Flixel. One thing I haven't shown you yet, I should probably show you that directly. Let's run this project, this skeleton project. So I have it in debug mode. You can release it as debug, or you can release it as release. And by the magic of compile definitions, you are able to so here it is. It's a black screen, but it's very useful for black screen because I have one of the very good features of Flixel is that it has a runtime debugger. So you can see here that you can pause the game here. You have some stats in here about the frames per second, memory usage, how many drawing calls you have. So when you call log and you log error, when you output an error line or a notice line or info line, it comes out in here. You also have a watch interface. So you call flxg.watch.add, and then you can say, I want to watch the Y property of this sprite, and it will appear in here, and you can inspect it real time, and you can change the values real time. You also have here a console, which I haven't used ever, but well, you have things here like, I don't know, I can write helping here, and allows me to do some things in here. This is quite advanced stuff that I haven't been able to use. And there are some other useful things. I don't know. Well, these are the tools in here. Apparently, this is one of the newer stuff that I haven't used. But apparently, you can change the position of the sprites as you see fit with these tools. This is rather newish, and I haven't had the time to use it. But yeah, that's one of the cool stuff in here. If you work with HTML5, then one of the things that you also want to do is not just debug things through here, but also debug things through the console. So a very useful thing in here is that if you use the sources in here, the Haxe will generate a map file for you. So you are able to use the well, this is an old file, but if you add the source directory to the if you add the source directory to your to the console, then you will be able to step directly through the console, through the Chrome console, and you can set breakpoints and stuff. And the map file will do the mapping between the JavaScript that it generates and your Haxe code. That's very useful as well for debugging. So yeah, log is one of those front ends. The other one is watch, as I told you. So you have an HTML5 front end that is only available if you compile to HTML5, and allows you to know which browser are you on, whether you're standing on mobile, and well, useful if you want to have, for example, a controller that only appears where you're using it in mobile instead of using the keyboard. And you also have random, which allows you to call random the random functions. It used to be an FLX random object that has static functions, but now it is part of the FLxG object, and this allows Flixel to become a little bit more deterministic, because Flixel is able to record the player's actions and is able to replay them, and that allows you to. This gives some determinism that's very useful for that and for things like network gaming, where you need your game to be deterministic. And well, you also have sound, which you can play sound files. If you make games for HTML5, you have to remember that you have to use OGG files. You have to export them. You can use Audacity for things like that. And yeah, you have other front ends such as save. You can handle save files through there. You have the console, which you can interact with the console that you saw earlier. The debugger as well. You also have the input front ends, which we'll see at the end of the talk, and the VCR, which allows you to play, to record the plays and pause the game as well. So collisions. In order to have collisions, you call an FlxG function that's called collide, and you can have collisions either with a sprite against another sprite, a sprite against a group against another group, and a group within itself. And you have the you can see that in the examples. So the way Flixel handles collision is that the sprites, when you create them, you have a square that is always aligned to the axis. So it's called axis aligned bounding box. So that way the collisions are very simple, but they're very effective. The only thing with that is that, say that you have you're creating, it happened to me, you're creating a top-down game about a motorbike, and you create the rotations for the motorbike. But since the sprite that it creates is a square, then the collisions are not very precise, because if the motorbike is in this direction, the sprite still has this dimensions, and it's a bit messy. But there are ways to get around that, and there are integrations with other libraries that might help you to have more complex collisions if you want to. The Flixel collisions are very simple, but they do the work most of the time. Yeah, so that's collision. A more detailed version of the collision is the overlap function, and in this case you have, well, in the previous step you can set the objects and the groups as the first two parameters, and then you have a notify callback. So in the case of Haxe, in order to specify a function parameter, you set it this way. So this is a function that accepts two dynamic objects, and then it outputs void. In this case, it doesn't return anything. And the notification callback allows you to call in the case that two bodies collide against each other. Okay, this happened, and this allows you to, for example, if your hero collides with an enemy, then you can subtract health from the hero and things like that. So a more advanced version of collisions is the overlap. In fact, this is what the collision uses. You said that both objects you want to collide. You have a notification callback in collide, and then you have a process callback. So how the collisions happen? The collisions in HaxeFlixel are very efficient, and they do it because all the objects are loaded into quad trees, and then that way it's an optimization that it uses to have faster collisions. So the objects are set into the quadrants of the quad tree, and that way you know that an object in a certain quadrant can't collide with other objects. That way it's very efficient. It's very efficient collision, and you can have dozens, hundreds of objects in screen. They can collide without losing frame rate. And well, in the case of the overlap, the process callback, what FlxG collide uses an FLX object function that is called separate, and that way when two objects are overlapping, then the separate object is able to calculate how much distance they must be separated in order to be next to each other, and also calculate the velocity of both sprites have mass. So you're able to, so when they collide, they have a certain collision response. We can see that in another project, small project that is online. So I'm going to close this one for the moment. Woo! I'm going to close this project, and I'm going to open another one, which is online. You might want to check that code. It's just a summary of the things we've seen here regarding sprites and collisions. So just to demonstrate how collisions work. So in this case, this is the character that I talked to you about earlier. It has the animations in here. That's a tile map that we'll see in a minute. And this is a box, which is a sprite. And when you collide the object, in this case, since the object has no drag, then the object will just follow. It works. Like in this case, if I fall over here, then it collides against this point. And we'll see that. We'll see about that in a minute. So yeah, we've got timers. So timers are allow you to call functions ahead in time. So you create a timer, then you say, I want to, in this amount of time in seconds as a float, I want to call this function. The function here accepts a timer, which is itself, and then you set the number of loops, the number of times that you want to run. So the good thing about the timer is that it's centrally managed. So in the case that you add a timer for something and then you pause the game, then the game will also pause the timer. So the timer won't set off. And that's the same case with the tweens. So in the case of the tweens, imagine that you want to have an object that is in here and you want to move it to another position. Then twinning allows you to do that easily. In this example, I'm twinning the alpha property. So you pass an object and then you pass a struct that has the names of the parameters and the target and the target that you want to reach. And you can set as many as you like. You can twin here at the same time, alpha, position, rotation, whatnot. You do it in the time that you want to do it, and then you pass some twin options. So the twin options, I put the options here for convenience, but well, you have a type in here which allows you to say, I want to twin this once, I want to twin this in reverse, I want to twin this as a ping pong thing, so it comes and goes, things like that. You also have an ease function, which is very advisable that you use it. So instead of a linear motion, you can have something that starts very quickly and becomes slower at the end, or that can do some bouncing things. All of that is part of the Flixel API. You can also call a function when it's starting, when it's updating, when it's complete. You can delay the start, or you can delay the loop. So, and in this case, the type that has this structure, that means the question at the beginning means that it's an optional parameter, so you don't need to set all of this. You can only set what you need to do. And also you also have these static functions that allow you to do very specific stuff like twinning a number, twinning an angle, a color, do some linear motion, do some quad motion, like a Bezier curve, circular motion, and even establish a path. And all of that with easing functions. You also have the tilemap. So the tilemap is loaded as a strip, as well as you saw before, and you can load it from a 2D array. You can load it from an array. You can load it from a CSV, and you set the frame numbers in there. This is a very annoying way of doing it. There are better ways to do it. You can use a tile editor such as Tiled, or well, I used one a long time ago, but I don't think it's been maintained for a while. In any case, you pass the sprite strip, and then you pass the frame dimensions. And well, when you do that, the result is this, the same result that you saw earlier. And you can have collision within the tile map, which is very helpful. Oh, you also have with the tile map, that's something that I didn't add in here, but there's a very useful functionality from tile maps, which is hiding. So if you do your tiles correctly, you can have HaxeFlixel determine how the tiles are connected based on its neighbors. So that way you can specify the level in a very simple way, like this is a block, this is a block, this is a block, this is a block, this is not a block, and then HaxeFlixel will determine, oh, you're doing here a curve, you're doing here an L-shaped block, you're doing here a T-shaped block and stuff. So it becomes easy for you to design a level. So yeah, I've shown you how to output graphics. But well, another important thing of a video game is how to read the input from a player. HaxeFlixel covers most of this. Since it's one code base for many platforms, most of the inputs are not available in other platforms. So say if you in mobile you don't have keyboard or you don't have mouse, and if you're in desktop you might not have swipe, things like that. But there are the conditional compiling defines which allow you to control whether you can access that or not. You have these are the other front ends I was talking to you about. So you have the keyboard, you have the mouse, you have the touches, you have the gamepad. I don't know if HTML can support gamepad, I'm not sure, but well, in any case, it's there if you want to make a game. I'm going to show you an example. So in this case, you have, I'm going to determine the velocity of an object, depending whether there is any of the keys I'm specifying in this array pressed. So any pressed means is the key pressed at this moment, regardless of what was previously. And that's helpful if you want to have a control, like if I want to walk, to make a character walk, then I press the button and then that character keeps walking until I stop pressing the button. But you might want to detect a pause. So that means that I want to press a button and I want to detect the object, to detect that event just once. So if I keep pressing the button in the next frame, then that means that the event has no longer happened. That in Flixel it's called any just pressed. It's helpful to this language is repeated in other inputs, like in the mouse. You also have any pressed or any just pressed. That allows you to know when the event has just happened. What else? Well, you have add-ons. The add-ons are things that are not core for HaxeFlixel but are very useful. So you have loaders for skeleton type tools, and you also have loaders for tiled or for other tools that allow you to make levels or things like that. So you have those loaders. You also have interfaces for Congregate or Jolt for interfacing with those platforms. In order to have the add-ons, you simply uncomment the line that says HaxeLib name Flixel add-ons in your skeleton, or you type in the line. You can also interact with. I told you that the collisions in Flixel are functional, are nice, but sometimes they might be too simple for something you're doing, and it'd be nice that you had some sort of rigid body simulator such as Box2D. Well, you don't have Box2D, but you have Nape, which is just as good. I've used it. You have the direct interface between Sprites and the Nape system. So the HaxeFlixel will set the sprite positions just as if you together with the Nape information. You also have some effect sprites that allow you to do some things with the sprites, such as like some sort of waving effect or some kind of echo, like some kind of ghost effect. But these effect sprites come from Flash, which and Flash had some sort of, well, it had a filter function that allowed you to modify the bitmap very quickly, but that hasn't translated very well within HTML5. It uses a CPU for it, and it's terribly slow. I've had games that in Flash run very well with the effect sprites, but when I translated them to HTML5, became very slow, way too slow, and I had to disable them. So what else? I have described HaxeFlixel in general good light. It does have some little quirks. As I told you, FlxG might be hard to comprehend. The thing with HaxeFlixel is it tries to do everything, and in the road to do everything, you also miss on the documentation. So for someone who enters HaxeFlixel for the first time, there might be a lot of functionality, but it's hidden away from you because you don't even know that it's in there. So that's something that that Flixel has to work on. It's a very good tool for prototyping, but if you try to deviate from the tools that it gives you, you might have a hard time as well. So, well, those are things that happen with it. But for most of the projects I do, it's quite useful. And well, the slides are in here, so and it has the speaker notes, so you can open it at your home and explore it at your leisure. It also has the documentation, the tutorial, which is very nice. It's very well written. And yeah, that's it. If you have any questions about how to use it, you have the forum in HaxeFlixel, and you also have the Slack channel, which is attended by very nice gentlemen. And well, if you have any other questions, you can do them right now.
So the last time I used this framework.
Sorry?
The last time I used this framework, I had a problem. As any developer coming from Flash or whatever, we are used to have containers. Containers do.
Containers.
Yes, containers.
Mm-hmm.
They contain other projects and they position themselves in a space.
Mm-hmm.
The problem I encountered is that the FLX group, the Flixel group, can contain sprites inside of it, but it doesn't position itself with the X and Y. Is this still a problem in Flixel?
Yeah, so your question is that is that when you use Flixel as part of Flash?
No, the question is group in Flixel positionable?
Yeah. So what happens is that the question for the streamers is that whether the sprites that are inserted into a group are positionable. So I'm going to show you the what happens behind the scenes. So when you have a group in here, so if I have I have to add it here. So I'm going to get into the definition. So a group is a generic, so it's a part of a generic group, a generic class called type group, and it contains objects of type FLX basic.
Yeah.
So that means that when you insert a sprite into a group, it becomes an FLX basic, which is not a sprite.
Okay.
So the problem that you had is that you tried to set a position for the entire group, right?
Yeah.
And the thing is that it's a group of FLX basics, so you don't have access to the parameters of X and Y and stuff. Because this is supposed to hold things like tilemaps and stuff which are not a sprite, are not even FLX objects, are not positional.
It's basically a collection. Instead of being a display object, it's a collection.
Yeah, so instead of using FLX group, the solution that has been devised for your case is that you have an FLX sprite group. So FLX sprite group allows you to add sprites to it, but you can still set the position for the entire group, and it will set the position for all the sprites that are inside it.
Thank you.
So yeah, any other question?
When you're making your games, which platforms are you usually targeting?
Well, I have to say that I'm a sucker for browser games.
Okay, so HTML, I guess.
HTML. It took me a long while to get used to HTML5, in the sense that I was always quite attracted to Flash's capabilities, and HTML5 has. It's been a slow road, but it's a road that I can live with. And I've targeted Windows as well. It's nice, but well, the distribution. I think that the problem is always the distribution. And HTML5, as Flash did, it solves the distribution problem. You just give a URL and people can play your game.
I'm not sure if it's that's possible, but would you be able to show us your favorite game you've made?
My favorite game I've made.
Yeah.
Well, I'm going to show you the last game I worked on. It's going to be personal, and I'm sorry if the thing is that, as I mentioned you, I'm from Venezuela. If you've read news from Venezuela, don't think that things in Venezuela are that bad. They're worse.
Yeah.
And one of the things is that there have been protests in the past 3 months, and I live here, I read the news, and I feel bad all about that. So one of the things I did was make a game about it, about the things that are happening in Venezuela. Not to rally you or anything. It's just to show what's happening. The cool thing about it is that lots of other developers, Venezuelan developers, joined me, and they made all their own games, and we did a Venezuela crisis jam. That's what we ended up doing. So I did this one that's called VZLA, and so this one I liked it. I couldn't do as much as I wanted because it was just a 2-week jam, but I intend to keep working on it. So in this case, well, I have some controls in here. I intend to be mobile game, so you can show an on-screen control in here. So when you say I want to show this text, I want to move the camera this way, I want to set this character to be able to control. So there was a deputy. So people were protesting, and the guards were taking the protesters, and there was this deputy that since he had parliamentary immunity, he blocked the guards from taking people away. So that was something that I wanted to demonstrate with this small game. So yeah, it's not very long, but well, it's something that I've been very happy about because it's a collection of things, of technical knowledge I've had about Flixel that came all together. But yeah, sorry for the political minutes.
Thank you.
And well, thank you very much. You can find the slides at this address, and well, you can write me at my email address. I think I wrote it here at the beginning. If not, it's my first name last name @gmail.com, or you can follow me on Twitter. I usually tweet in Spanish or English, but well, thanks very much. Thanks for your attention.
Thank you. All right, because we have a 5-minute break. I was just thinking, the giveaways, do we want to put our names just in the hat? Just write your name
Oh,
on
yeah.
that. There's a couple
Yeah.
of giveaways.
It's about time.
Yeah.
Good job, Ron.
Trying our best is not high profile, but yeah, just write your name on a post-it. We'll just yes, I have.
Oh, a proper hug.
Yeah, yeah.
No, why?
My adult
Should do it in front of the camera so it's nice.
I know, right?
Do you have money there?
No bunnies, unfortunately.
I might have a gold set. But I think black. I've got these which might be easier. The slides I haven't yet done yet.
And I'll put my name in as well. There we go.
Well then you're bound to it and then I think it's with.
Yeah, guys. That's awesome. Thanks, dude. That was great.
Ah, thanks, man.
Yeah.
I have bad news, but I think I have to leave now.
Fine? Yeah, that's fine.
Yeah, for the winner of the game.
Yes?
Just get him his email, and
Okay.
I'll give him the game through the gift.
Great, thank you so much for that. Yeah, yeah.
But well,
No,
thanks,
it's
and
amazing.
I hope you keep doing this.
Yeah, no, it's
Even
brilliant.
now
It's
you have a
always
bigger, you have a bigger.
challenge, always, but yeah.
Oh, sorry. I was busy trying to get my slides together because I was paranoid they weren't quite in the right order.
I'll watch it.
Yeah, do too.
I'll do questions. Because
That's getting them all in the right order.
okay, take your time.
Well, it's all done now, but unfortunately I didn't manage to watch that. But I kind of know OpenFL really quite a lot, so I will watch it that way. I thought it's better to try and get my bits.
But I thought you were using Lux or stuff.
Well, I've got Lux, OpenFL, Enemy, JavaScript, just a bit of everything really, just to make people feel, because I've been writing for Post-it.
You enjoy it?
So lots of simple stuff. Just that flexibility to be able to just.
Do you work commercially with Haxe?
I have done. I'm not at the moment. I'm not working at the moment.
Okay.
I was working for a company that was funny about my own open source. I'm the manager for
Well, at least that was at least.
That's hard. That's hard. But is your stuff still on?
I've been putting it all back up. I've got some more stuff as well. So I'm going to go through some of that. It's in the news. It takes all your week to do that. So I'm going to go through that as well.
Which can be good and bad.
No, I did all this stuff I was doing before I started there. It was just obsessed about saying, they were trying to sell the fact that they're all doing it.
So your one is like actually four. My one is my two and yours.
It's not specific, it's more specific games. So I got that and the manager was they've given me loads of work on something nothing for ages. And I just recently suddenly they called up, they would talk to me and they just send me this thing. Everything in the normal voice is really good.
Not even the voice.
Keeping it running.
Yeah.
The Bristol Bath area, so it's not quite so easy to get stuff.
I'll think about your games. So usually
I've got quite a lot of hacks, but
when you're a game developer,
nobody's
at some point trying to do games not just because you like the games, but at some point you want to try to make some heat to get some profit from it, to get some, I don't know,
But I've done
so you can pop it out, but as a kid, we were doing games, we were doing drawings, not because we are artists, but you just enjoyed the stuff.
website was
Maybe
Sand.
when you were a kid, you didn't have another good. Yeah, hungry.
Early days, really. Before I
Well, yeah.
let's put this in.
So it is strange.
Yeah, that's an instruction.
Yeah, exactly. This guy is like a.
I think the best site for English speakers
Yes.
is Caracas Chronicles. Caracas Chronicles.com. It's a website that specifically there's a series of comics written by Naki Soto. She writes daily something what's been happening because things that happen all at the same time. And I think she's one of the best writers that Caracas Chronicles.
Just like the name of the
Oh, see, the name is right. N-I-K-Y. But you'll find her, like it's you'll find her. What's your name? She writes in Spanish.
So,
That's right.
sorry, you mean this very simple, right? Very popular.
Oh, really?
Yeah.
And got very lucky. Because you are
Biggest influence ever. Exactly.
so you had lots of money and you are grand.
And he was lucky enough to
No, it doesn't work. But
Oh, you did leave this to finish that.
So I think that he's doing now. He would have done it.
yes, I think it's it would have the same reflex.
But yeah, Kurt's trying to in a very
So one thing that's my favorite right now is difficult mind.
People went to jail.
Yeah, definitely.
That's true. The thing is that Bitcoin mining in Israel is very expensive. We don't pay very little stuff. So people but basically they
They have so the customer is like an optional parameter to a function, like a function or a parameter can run off. I guess if you need one parameter, you can get it out.
It depends on the parameter. You can set the same. You can set
It's
the
like
parameter
different
such
way,
that
okay, go.
You almost ready?
but it depends also. I'm not very sure how
I'm just
when you have a no
yeah, no, I was just trying to find things before I started.
They give us a show.
The other thing I'm going to bring this last step.
Yeah, I'm gonna box below and then I'm ready. Is that the right size?
Looks good.
Let me just check the
Yeah, looks good.
yeah, the reports are
I know what you mean, but I don't have
Bye guys.
See you, guys.
Yeah, just a couple minutes. Set up.
Yeah, I like those styles.
Is that working your camera? Ren?
Are you asking if we can see them?
Yeah, is it set up? Is that look
Yeah, we can see the screen here with
yeah, does that look okay?
it looks alright. It has
Yeah,
like
okay,
a
I'm gonna
light,
pop-
has like a light source
Yeah.
reflection. Yeah, but it's not a biggie.
Is that? Should I move it?
Yeah, it's like not ideal, but it's fine.
Oh, right, okay, that's a bit annoying, isn't
Yeah,
it?
certainly we can see all the.
Pop below.
Ready.
But then I guess
Yeah, just to make sure it's abstracted a lot, because if you haircut some stuff and you try to extend and make some function, it's gonna be a nightmare. Yeah. I'm very young as well, I'm a 5 to 8. After a couple of months, I played your game. You already like experienced player, and you say, okay, it's like fun, you know, kind of driving.
We need other people to actually play.
I was such thing with one of my games. I gave it to some of my friends.
Yeah, he was like,
And then, well, no, I think to drive, there is 1 minute, and different cars, that's why I went, hell, what should I do here?
exactly. Yeah, it is also important. The feedback loop.
Exactly.
Did you put your name? How is your name actually?
Well, officially,
That's how you say in Russian.
yeah. Yeah, what actually turns for me, Igor? Igor.
It's not the
Yeah.
same.
It's not the same, but yeah, it's like Georgi, Igor, Gora, Goga, and other stuff, and you know, it's like a little bit complicated
I remember the rest of it, like Alex and Sasha.
Yeah.
And you're correct.
Yeah, yeah.
Okay.
Yeah. And you know, Alex is Alexei and Alexander. And they are two different names.
I mean, I always have seen it.
They're missing like a address.
Those are the best.
I have one.
Okay.
Thank you.
Is everybody ready? Right, guys. This is just showing you car setup briefly. So you need to get hold of the Code Studio from here. This is at this address. There's a car explains it, but the way Robert explains it, he explains 2 different ways, and it's a bit confusing. So this is just the simplified way. So you need to clone. Now, when you do a car project, you clone an empty project, and then you recurse through, and it grabs everything. It grabs a copy of Haxe, his version of Haxe, slightly modified, copy of car, and all the other bits you need. So that's the first thing, and then so this is getting all the bits, and then you can just drag your project into car, the empty project that you've just downloaded. Just drag it into the code editor, and you can start working. So this is a simple example of yeah. So this is just drawing a triangle. So I'll come back to that. That was just to sort of show you that it's really not as scary as it seems. So what we can do is we can open code, and then we can drag the slideshow I was building last night into. So this is my little car project. That's my slideshow, and we can run it. So, moving shapes in Haxe. So when I say shapes, I mean all sorts of things. This gives you some sort of idea on the sort of things that we might think of as in terms of a shape, in terms of how we render it with lines and pixels and with curves, and shapes are fractals, and they can be images really in a way, and obviously shapes with holes in, concave, all the different types. So this is just a render of using this library called HaxeFlixel. Basically abstracts. It was something we developed when we were developing the Daedalus library, and it wasn't. I didn't develop most of it. It was the guy working with me, and basically it abstracts over OpenFL, enemy, JavaScript, Canvas, what else? Swing. I think there's probably some more. Oh, and Lux and Flambe. So basically, it deals with pixels. So you put the pixels into it, do stuff with the pixels, and then take it out to the thing you need. So this is so if I click on this, it will render. Oh, it's rendering down there. It will render a Lux thing just like that. So that's grabbed from Git raw and done on the fly. Sorry, it came down here. So as you can see, because I'm using that abstraction, it's one of the advantages of Haxe. I can create code that's written without knowing what platform I'm going to do it on, and then just hook some bits up later. So if we see car, so that's done it again. This is going to be annoying. But it's the same image. It's just I've taken basically there's a Rosetta code. There's a little Mandelbrot example. I've taken that and I've just played about with some of the colours and stuff to make it a bit more interesting. And the reason why this one's red is because the colour output is different, but you've got some controls in HaxeFlixel for changing the formats. This is a Flash one, and that's obviously so I've built that with only a couple of lines of code difference for car, Lux, and Flash. So, and I could do OpenFL, enemy, Flambe, JavaScript, Swing. So it's quite flexible. So that's quite a useful tool just for pixels. So that's one way you get your shapes. Now this is a Canvas experiment. In one of my libraries I've got, so if I click on that, now the animation works better when I run it locally, but this is from the GitHub raw. Basically it's just a load of images, offset, and it's like blighting, so I've got one canvas is drawn onto at the angle, and then drawn onto the main one. So for every leg, every piece of the leg, they're drawn onto a separate canvas first, and then onto the main one, and you've got the offsets all worked out. So there's a little thing called Leaf in my HTML helper GitHub that will help you use that for just doing simple animations like this. And what's interesting is the shape. I don't know how mathematical you guys are, probably more than 7 meters. Where's that gone? I've got that still up there. Where's the other one? Oh no, right, okay. So, right, generating curves. One of the interesting things about the last thing we saw, which I was meaning to talk about, was the legs are just moved with the sine waves. So that zebra, which does look more realistic if you tweak the animations, is just putting a sine wave with different begin and ends on every item of their leg. And you can make them look like they're moving with slight offset. So sine and cosines are great for drawing shapes and for movement. Now you've got Beziers, quadratic and cubic. And Spyro is something I ported to Haxe from a JavaScript and a .NET version. I'll get back to Spyro soon, and L Systems is something interesting as well. So if we, it always does this. It's because I didn't realise I was going to be working on 2 screens like this. So this is it's one of my early experiments with Haxe, and it's using. I thought, well, this was before Canvas and WebGL were very popular, and I thought, right, okay, I want to animate stuff like I can do in Flash, but I can't do that because I've only got divs. I can't rely on anything else. So these are actually drawn with strips of divs. So one way to draw is obviously with strips, and that's something you can use with Flambe, because Flambe doesn't have any triangles. I think Flambe is kind of dead, but if you do find it's quite used by Aardman have used it, so it's quite good to say that you can use it. So this does the animation. So this is using a Bezier quadratic equation. So similar, cubic, and it's come down here again. Sorry, I should have, can we size that slightly? Can't see the edge of the black. It's quite hard with the reflections. So we can do that, and we can move it while it's moving. So obviously we can use these for drawing shapes, curves and things. So this is still, oh, it's come down here. This is still drawn just with divs. So each shape is, the fills are drawn with divs. So and the lines, so each of these lines is lots and lots of little lines. And this, the class for this, it's a bit pointless in that way, but it sort of, you can sort of see how the theories, the technology changes, and the power of the technology changes, but a lot of the ideas are the same. So these are quite old experiments now. Oh. So this is the div clock. So don't know, for the hell of it. Oh, it's come down here. So you can drag that around, and you can do this, and it might not break. It might break. Yeah, I need to fix that one day. But since it's not got any practical use, because nobody is going to need a div clock.
You never know.
You never know. If you ever have somebody who says there's no canvas and there's no this and that, yeah, you can do it all with, all these triangles are built with horizontal bars. So yeah. And the same with this one. Oh. Grab it. So modern browsers are quite responsive, because it's these gradients are made up with lots of horizontal stripes of divs. So yeah, that's, and they all move and whatever. So okay, so next Spyro. So that's Spyro basically is a type of curve that means that you put the dots on the curve, and it makes a nice curve. It's a Euclidean, I think it's called. It means that the curve. So this is it's something I ported. Now, when I click on this, the example doesn't work because CodePen doesn't work in. So we have to do CodePen from the browser, unfortunately. Don't know why CodePen doesn't work, but this is one I played with. So you can, it's the guy who designed it, so you've got modified points. It's a bit buggy because it's just a, maybe I should restart it. So you can create a path. And then you can modify the points. I don't know why. Maybe I've chosen a bad one to show you. I think there's a, yeah, that's probably just my bad coding on that one. I've got another example. I've got one I did with triangles and WebGL somewhere, but yeah, I've linked to that one. So sorry, my bad.
Sorry, can I have a question?
Yeah.
How does conception differs from Bezier except for the containing?
Because if you want to do an S, or like for instance, if you want to do an O, you can do an O with 4 points.
Yeah.
So in terms of, it's GPL3 unfortunately because of the original author, which means it's useless. But it's also easier to draw with.
Okay.
So you can because it does these curves. When you move the points, it's more intuitive.
All right.
If you've ever moved Bezier stuff around, it's actually what's used in Inkscape.
All right.
So there's a thing in Inkscape.
So basically, the fact that it goes through the points makes
It goes through the points and it curves. It's like a circular shape. So when it moves, it just moves more instinctively.
All right.
Because Bezier's not designed to be fast on a computer, but Spyro is designed to be easy for people to use.
All right.
So what you can do is, because this actually outputs Bezier's, you can use it for a drawing tool that you could have in-house, and then you could create the beziers and then put those in your game. So yeah. But yeah, it's a bit annoying the license on it. I wish I could. I've written to him to ask it. L systems. So the idea with an L system is, I'll probably have to run it, is you have a bunch of letters, and as you go through the letters, you either draw some lines or change an angle, or you branch. So you can make these branches. So if I run this, oh, am I quick enough? I need to, you can see, so it's like a 2-loop system. The first loop creates how many levels of iteration you want, and the second loop renders it to the screen. So it takes the letters, so it's just a string. It might be A, B, C, D, brackets, A, B, C, brackets, and then, so you get more and more letters the longer you do it. So what we can do is, obviously, we can make some lovely patterns of that, and shapes. So this is an output of some shapes, and this is the animation of them. Now, it's quite a slow to render, and I think it's worth watching because it's quite cool. But these are just common L systems you can get off the web and adjust and tweak, change the colours. The original one was, the L system library that I took was not mine. I took it apart and I added stuff so I could do colours to it. I added lots of examples, and I did something else as well. Oh, and I made it, obviously the original wasn't animating, but basically you animate the second loop. So in a minute it's going to change. It's a bit slow. This is why I brought some music. I was going to play the music while it was on. But I think there's something.
Could you show the strings which have been used for these lovely shapes?
The what? Sorry.
Strings.
Yes. We can do that in a minute. Just let the animation.
Sorry.
So this is the second one, which is a bit more exciting. Somehow I need to speed up the first one, but so you can have a range of textures and stuff in an engine, pre-render it. It's probably a little bit slow, but most trees that are developed in Blender and stuff like that are done using these simple L systems. And if you look at the code, the way it's done, I've abstracted a bit, so I think I might be able to get it to do in 3D, but I haven't got around to that yet. But it's just getting the setup right. So we can do, let's see what I can find the code then for you. Well, it's a Lux project, which is a bit of a hassle. So this is the code. So that's the setup for since I'm here, I might as well show you. That's the setup file you normally have for a Lux project. So you just sort of name and packages and all the normal stuff. The kind of stuff you end up looking up. So I've got two versions, animation and iteration. And can we run it easily? Let's see. Which one? Let's run that one. I might have to do it from terminal. Oh no. If anybody knows how to get Haxe to, so these are the different ones. Is that what you're after?
Possibly. So basically.
Let me do the other one because I think this one's probably more complicated, and I think the other one's what you want. So if we do that one. It depends on the first iteration builds the letters. So with this one, you'll see console. You'll see the letters change.
This is just a concatenation of same string, all of it.
It's just rules added to the string. Let me show you the code quickly. I don't want to do all the talk on this though.
Sorry, it's very interesting.
No, it's all right. Oh, it's really annoying because I have to bend my head to think. So that's the basic L system.
Yep.
I've done some abstractions on terms of. So this is the state stack. So yeah, that's not two nodes. Straight node. So I'm just right. Okay, so these are the shapes. So I'm trying to think which one was. I think it's probably that one we were looking at. So these are the. You said
I see.
options,
Okay. Makes sense.
yeah.
Makes total sense.
And
so
then
looking at those things, you think they would be symmetric, and which is the case for most of the shapes, except for the yellow tree, which is a bit weird.
the yellow tree is just a tree that's gone sideways. It just depends on whether you.
Yes, this one. How does Helen is not symmetric?
Because you change the angles. Look, here are the angles.
Oh.
So left and right. So it's a left and right fork thing.
Oh, I see. So
Yeah.
it's not a.
So this.
Okay, makes
So
sense.
you switch
Yeah,
on.
there's a switch. Yeah, makes sense. Makes total sense. Thank you.
Yeah. Sorry, I kind of you need to play about with it, and I can go into it, but we could do the whole talk on just them. I think.
It's enough.
I'm quite happy to show you
Curiosity
afterwards.
is fine.
But yeah, almost live coding. Trying to remember stuff because I've not been working on that today. Right, okay, so on that one. Okay, so this is in Lux, this is how you create a triangle. Now that's quite important because it's GL accelerated. So those triangles you can put hundreds and thousands of them on the screen at the same time. So that's a triangle. And obviously, well, there's the setup code, which we can go to. Oh, see, I can't type when people are watching. I think. So you have a little bit of setup code, which is fairly, that's kind of template for any Lux project. It's going to be sort of something similar to that, and then obviously then you have your triangle code. Yeah, so that's online. So this is the first step towards drawing with triangles rather than drawing with flash curves and stuff. Is that the? Oh, that's the other one. Where's the other one? Where's the other code in there? No. Ah, I can't see it. Looks like code, doesn't it? Where's my arrow? Right, okay. So this is what you need for car to do it. Car's got two graphics module, but it's just got 3 or 4 graphics approaches. It's got G2, G4, which are the ones that you will use most. G2 is for doing 2D graphics, and G4 is for doing 3D graphics.
Makes no sense.
You've got G1 for doing pixels. So when you're in 3D, you can draw them on top of each other because they're kind of inherited together. So you can actually put 2D and 3D and mix them quite easily and draw. So you basically just draw onto G2 your frame with your G2 and your G4, if that makes any sense. So for filling triangles, there's 3 libraries that I've kind of used. PolyK is a JavaScript library that I ported over. poly to try HX is probably the best solution. Because it deals with holes quite well. But you need to do some speed tests and see what they're like. And Triangulation is one that I'll show you later that I ported and then realised it probably wouldn't be fast enough. But it's quite interesting because it can be used for physics because the way it works. But we'll come to that later. So this is poly. This is not my example. This is poly to try HX. If you go to his repository, this is one of the examples. Probably using Flash. Okay. So this is polyK example. So it breaks up that shape into these triangles. Now, because I'm now I'm not filling them because I'm still using divs for this experiment. I have got some other experiments somewhere that use it. So it's, but considering it's retriangulating every time, redrawing all those horizontal divs every frame, it does quite well. So yeah, you can do a lot with divs if you have to.
How was it performing back in the days?
That was performing well. No, that one's quite slow, but the other div ones were working fine for years. So I don't think the improvements in the web stuff has improved because that was back in one of the Haxe talks a couple of years back. But this is drawing points along a curve. Now I can show you the maths and stuff I got involved in, but it gets a bit complicated. So it's more for fun in a way. So it's a bit slow because I need to change the settings. But at the moment, you draw 40 points. And see these paths, so this text was created in Flash, and then I used a tool to grab the path data from it, and then I have a little parser that goes through and takes the path data and makes them into drawing commands, and then I equal space the points that I'm going to use and just use lines so that I can then distort it. So there's two versions. There's one normal version, which is this one's just had some. This is normal text, and it's just had some rotation and some 3D applied to it. And this is a bit crazy. If I can get there. So it's basically what happens is the letters. You've got the line down the centre, and you take them and you work out where they are based on the outside line and the inside line. And you remap all the objects. So it's just a mapping of code. So that's not line, you're quite welcome to play with it, but it is quite like experimental stuff. So this is something I would love to be able to do in car and Lux, but I need to know more about shaders. I'm not very good on the shaders yet. So basically this works in Java Swing, JavaScript Canvas. This version is JavaScript Canvas with divs, so it's a mixture actually, and Flash obviously, and I had a video version that was running in JavaScript, and it kind of worked. So let me just show. So it's quite simple. Oh. So have to get it in the right place. The one thing is, people always rude about Flash, but actually it renders really clean in Flash. It doesn't render as nice in. But although the actual core of the jigsaw code, which you can change to have different numbers of pieces, and you can change the amount of curvature you're likely to get, the randomness. So you can have, so every time it runs, it will have different pieces. So you can see the pieces. That's one of my paintings. So you see the pieces. If you go, if I go backwards, you'll see the different pieces, different shapes. Now the reason why I find that hard to do in Lux and car is because they tend to work with triangles and shaders and images, and so you'd have to write the shaders for doing masking. I don't know, probably other people know how to do that. Something I need to look into more. It's just not something I've got to yet. Java swing circle example. So that opens that, which is not very useful. So this is how you set up the swing stuff. Let me see a bit more. So this would be your main class. This gives you an idea of your main class. And this is the J panel, and basically here you can see this is your paint function, and basically your paint function's here. So they want you to paint inside your component. You don't really, I don't want to paint, put little bits of code in there so what you tend to do is you abstract that out, and then you can do all your drawing commands up here in your main class or your graphics class where you're doing all your code, and just inject it into your drawing here. So they kind of force you into this sort of non-render loop system, but they do the double buffering for you, so it's sort of swings and roundabouts. But swing's lovely with Flash because it's really easy to use. It's like using JavaScript or Flash. There's no OpenFL setup or something going wrong because this HXCP stopped working with Lime or something. None of that. It just seems to work. So it's great to sort of just make stuff quickly. The drawing stuff's good. There's lots of support, and you can just use any jar you want. So that's really nice. I won't go too much into using Java, because there's you can use the jars, and I've got some more complex examples I haven't put online yet from the past. So that's the actual draw commands for in your draw, wherever you're going to put your draw function. Setting up SVG. So that's how you go around setting up your root SVG. And this is a project I've been working on. I worked on for HTML5, which basically abstracting the drawing commands. So just drawing lines and curves, beziers, so that you could use it with Java. So swing with Flash, Enemy, OpenFL, Flambe, Lux. So you can get the same sort of results. So I've been playing about with that in the last week or two, trying to get that abstracted out because it was all inside HTML5, which is quite a complicated thing anyway. So this is quite useful. So this is an OpenFL example. So that's online, so I can show you the code if you're interested. This is how a shader works. I don't know whether people know shaders, or it's probably all do. I don't know what the experience level is. But basically you have a two system, two shaders basically. The first one plots where it's going to be on the screen, sort of, and the second one plots the pixels. And you can do transforms in both of them. But that's kind of like C code that you sort of shove into your JavaScript. And if you're using or into your whatever GL language you're using, what's really nice about Car, and I think Lux as well, is they abstract it out so that you can use the same shaders. And they use the modern shader systems with the in and out. You can use that all in Car and Lux without WebGL. Don't change the shaders. Don't have to Metal. You don't need to change the shaders. So you can use all these complicated systems with exactly the same shaders, the same pipeline code. You don't have to worry about how it works. So this is doing triangles. So this is setting up WebGL for shaders. So you have to set up the, I mean this goes through it all, it's just, I don't want to go through too much of it. But you set up your two shaders, so these are strings you pass to your JavaScript, you send them to the GPU, and then this is your Haxe logo. You might have a load of triangles that you send, and then you set these bits on the shaders to do the this is the rotation stuff. So there's a tutorial here which I'm supposed to put in the cookbook, which sort of goes through it all, which you can look at. There's the it's all online. So this is something I've been playing, experimenting with. So this shape here is done with poly-tri, so it's got a hole in the middle. This is poly-K, and then this shape here is an SVG path that I've parsed. So if I show you, I wanted to show you parsing approach. So, rather than iterate through every letter in the array, you get the fast code. So you use this thing. This is supposed to be a lot faster. So you get the fast code, and this is how lots of the, if you look in format library in Haxe, it's got a format library. It will go through and do all the. It basically sets up this type of structure. So you have a while loop, and it goes through every letter, and then you have a switch. And you just put the letters you're looking for. So this will be the SVG. This takes the control points and this maps it to your normal drawing commands. So if I show you, it will map your SVG to these commands. And if you map those commands to triangles, you can then draw those shapes. And the way I've done the drawing of the shapes of the triangles is for a line you do two boxes, and then for the curves lots of little triangles. And it's kind of like that, but a bit more complicated. So it's kind of just a for loop, and it loops through. We can actually look at just triangles just to show you. Oh. So this has the same yeah, so the drawing commands get done here. So you first parse them, the path commands and drawing commands, or you can pass just drawing commands. This builds triangles, this shape, these goes off to build your triangles. And then you can, at the end, you can gather all your triangles to fill them if you want to. The fill's not brilliant. I mean, as I said, to try and do like any shape you want with just triangles, it's quite a lot of effort. So yeah, so that's. I don't know if there's any more questions on that. Oh, and what's interesting about this example is that you've got. So it's a simple car example in that you've got mouse movement, you've got drawing, you've got keyboard. So you can see how you can do all those in a car example. So it's quite an easy one. At the moment, let me see. So that's the G4. So that one you could actually just change the matrix and you could rotate it, which is quite nice. There's two versions. G2 version I've done, which is much simpler. The G4 you have to set up all your detail stuff and you can do your rotation. So, so this is a G, just to example, the G2 is quite simple. So this is your render loop. This is where you do your fill triangles. And then in terms of the drawing, this is your path context. You can set colors and draw. You can parse the SVGs, paths, just the paths. I have got code for trying to do SVG a bit more, but not that far yet. And the G4, graphics 4, sorry, I should say. I'm just a bit lazy. And I tried this with Flambe, with just trying it with strips. Doesn't come out very well. Where's the Flambe one? The Flambe one's crazy. It kind of kills the processor a little bit. Yeah, so I'll show you the image. It's a bit broken. That's done. Each triangle is drawn with strips. So G4. So you have to set up the vertexes and stuff. It's very, very similar. There's a guy called Lubus who's doing a really amazing 3D engine that works in Blend, and it basically runs car in Blend, in Python, and then exports to WebGL and whatever, all the different things. But he's written this lovely engine that you can use. But he wrote some 3D tutorials, which I found really easy, based on some well-known tutorials for car. So Lubus is definitely the one to look for understanding 3D in car. And this has changed a lot. It keeps on changing, so keep on having to keep. But this is the stuff for rotating. So you can use this fast math stuff. And this is the different tests. I'm trying to get to the render loop. So this would be your render loop here. This is where you're pushing your vertices on. So that example I showed you was actually building all those shapes each time real time. It didn't need to, it was just to see how well it worked. So it felt a bit laggy because it was trying to do an awful lot. So, was there any questions before I close that? No? Okay. Oh, that's just another one of those. There's a Lux version and a car version. Okay, this is the dataless library. Will that take you to the right place? Yes, the dataless library was the one that it's got HXPixels in. So as F7 went off and created, do you know how you say his name? I don't know how you say his name. As the HXPixel stuff, and then we both worked on the just drawing stuff, which is called Wings in this library, but I've been abstracting it recently. So you can draw all these things. So if I open this in a proper browser, because a video won't run properly in the code window. Now this is an AS3 engine we ported. Obviously it only did AS3 when it started, so I got it working, nearly all working in Flash, ported it all, and then I asked Asif for some help. So we then got it working, and then using the stuff that I've done in Divtastic and with the jigsaw stuff, bringing it all together, and then stuff he brought in, we kind of got all the bits working so we could get loads of platforms. So what's nice is, there's a video here. I think it's quite fast in a minute. It's a bit slow to begin with. So this is one of his examples. Is it running? Alright, so you just click anywhere. So basically that takes, what you can do is you can give it shapes, or you can give it bitmaps, and it will triangulate it, and then use the triangles to work out the best path. So it's quite a useful library for games, ideal for games, because if you want your character to go to the other side, you can use Polygonal's AI library to do a proper A-star graph system, or you can use dataless, which means you don't even need to, you just give it a picture, or you can just give it some objects and you can move them around and stuff. This is Galapagos Islands. That was one of my ones. As you can see, these are the swing now. And this is what's so nice about Flash, is when you abstract some bits to it, you just don't care what language you're in. Because the code, the maths, all the hard maths, the hard bits is done. So the polyk stuff that I ported now runs in C# or PHP or whatever. So that's what's really powerful about Haxe that people don't realise, is once you get your code in a format that's abstracted, business. Canvas, is it doing some more? Right, still. So that's that one. There is an, oh. So in terms of the different libraries, so you've got enemy and OpenFL. That's the simple drawing stuff. That's what I've taken off to doing just drawing, and that's just showing just the basic drawing abilities of it. It's a Flash example, JavaScript example, a Lux example. So what's quite nice is, for instance, I think this might need updating, but in the Lux it gives you sort of some idea that I think this has probably changed now, but it's quite good because when you forget how a different setup works, you can go to look at one that's sort of got the core that's the same, and you've got the same thing done in lots of different ones, so that's quite useful. And then you have to go into their documentation to see how to do fancy things. So that's Flamby, which is kind of a bit dead, but so for instance, is it going to work? Yeah. So fills are difficult in Flamby. So with drawing, because it's a kind of like Lux and like car, but it doesn't have fill triangles. So for instance, the Lux version might have fills. I can't remember. So we can look at a different one. So these objects you can actually move in real time. So you can imagine that's quite useful for doing pathfinding, getting to your desk, or if you're in a big office, or if you're trying to have soldiers fighting and stuff. So it's quite a useful library. I'm sure it can be improved. Okay, so what have we got next? Where am I? No, it's not that one. This is the Triangulations engine. So this is using just triangles, my thing, and this is a WebGL version. Theoretically it should work in car. What's quite nice is that the tests that he'd written using some JavaScript code, this is all now WebGL, so all that's generated. The reason why this is like this is because I did a font in simple font. I mean, it's a lot more work to do. Really, I should use images, and it's just for testing it. Probably was overkill to put words on the screen. So and then as you can see, because it's WebGL, you can just do what you like with it, distort it, put filters on it. These are some of the tests of the library. So detect whether it's in or out. So these are things you can use in games. This is a bit of a weird one. As it goes round, things change colour. It's to do with the angles. When you've got the triangles, you're trying to make them as equilateral as possible, or to a certain extent, to get a good triangulation, because it's better for physics. Lots of reasons it's better, but it can be heavier if you just want some triangles to just draw something quickly. So we've got this. and detects it. It's detecting when it's in the red circle. So this is triangulating on the fly with a hole in it. I don't think it's perfect. You can certainly destroy it. I think you'll find the polytry thing better. But remember, all these images are drawn with millions and millions of triangles, so it's a bit crazy. And this is to show this is how you break up the triangles. So you try to see which by swapping angles, which triangles work better. And then you can see. So I'm probably not explaining much. I'm just going through the examples. So this is detecting which triangle you're in. And this is split test. So this is how the Rupert basically does the standard triangulation and repeats it lots of times to get by doing this sort of testing, which is so you're looking to get the best triangle. So and this is heavy. Oh look, and it's changed the shape. It's quite heavy. So this is trying to give nice triangles, but you can tell it how nice you want it to do the triangles. And it basically iterates like 23 times or something at the moment. It depends, you can set it differently. And it'll go through and improve the triangles all the time. So if you wanted to had a shape that you wanted to get some physics working on, you need a nice, or in real life, like for doing proper physics, you want an object to have nice triangles. So there is a purpose of it, but when I talked to the guy who originally made it, and I had to rebuild it, it was really very functional. I've kind of made it a little bit in between functional and OP. So yeah, how are we doing for time? I don't know.
Yeah.
That's kind of.
That's good.
Yeah. Was that interesting? I don't know if it was interesting. Any more? I mean, I can go through specific code if you want. If there's anything specific, we can look at it.
Well, actually, about HTML5, it's quite interesting when you pass an image to library. Yeah.
Yeah.
And you try to triangulate it.
Yeah.
How do you detect like edges and points, like anchor points of shapes of other stuff?
Let me see what I can
If
do.
you can briefly cover the algorithm, it would be like awesome.
Yeah.
I mean, even if it like roughly.
So in terms of triangulating it.
Yeah.
Right. Let's see if I can find the HTML5 code. So in the code, it's a long time since I've looked at this. That might be a question I can't answer off the top of my head, because it's been a long time. But basically, use the HaxeFlixel code
Yeah.
to work out where the shapes are.
So you detecting shapes with HaxeFlixel, right?
It's turning. Well, it's taking your. Yeah, it's not probably doing the shapes actually. So let me see. There's a function. I've just got to find the right. Oh, I think it uses a portrace. I don't know if you.
Here it goes through the image.
So builds the shapes by going through the pixels. Don't know to be honest.
Yeah, well, as you can see, it like detects the nodes, right? And
Yeah.
then based on nodes, it builds some polygons.
Yeah, and it does simplify it as well, as you saw. There's like once it's got like a rough idea of the shape, it goes through and it's got some code for trying to using this is distant point squared. So you use these circular things to see if the triangle, if the circle is within the triangle, then it doesn't try to circle. The circle tells whether it needs to triangulate it more. So that's kind of how it knows how to simplify it. Yeah, sorry, that's not a very good answer. I have to come back to you on that one.
Yeah. But yeah, quite interesting library, so and quite useful.
Quite useful.
Yeah.
I mean, some of it I understood a bit of it when I was doing it, and now I've forgotten quite a lot of it.
That's right.
Because when you're porting somebody else's library, you sort of some things you understand better later, and other things you don't understand at all. So, yeah.
Cool. Should we wrap up there?
Yep.
Nice.
So,
Thank you so much.
I hope it was alright.
Yeah, it's great.
Yeah, thank you, man.
Yeah.
And there's all the stuff's on my repository that's there. And if you want any fantastic stuff, I can put some